Okay, record it for everyone who wants to watch it tonight. All right, guys, let's get this started here. Wherever you want to start, questions, specific questions in general, specific questions here. Go ahead, Malia. Go ahead. What do you have? Or Peter, go ahead. Sorry, Peter, go ahead.
Can you go over question 13 on page 610?
Okay, so page 610. Sorry, I just got to keep admitting people for some reason. Okay, page 610. All right, I'm on 610. Which one?
13.
13. Find the geometric mean.
Yes.
That's not, you don't have to worry about that. That concept's not going to be on there. That's kind of what we did with Hill before I introduced Hills and Sass, where you multiply them and you take the square root. Don't need to worry about geometric mean. Okay. It was just something we did before I introduced Hills and Sass. Okay. Where are we going here, guys? You guys lead the way as usual here. Hopefully I didn't scare you today during class with everything that was going to be covered. I usually, during this COVID situation, I don't like to do full unit tests, but I thought it was needed for this unit. So is there a topic? Is there specific questions or anything just in general you want to throw by me?
Can we do something with angle of elevation or depression?
Elevation or depression, sure. Let me go. Was there anything? Let me first start with the packet work. All right, I'm in the packet right now, page 54, number 4. Page 54, number 4. I want to remind you guys again that tomorrow during the test, you do not need to know where to place elevation or depression because I will already have the diagram labeled for you. You can thank me for that later. Okay, so this is in your packet, number 4 at the end. I do have to label some of this already. All right, so you got at 10 a.m., a person observes a hot air balloon. Yep. A hot air balloon climbing vertically in the air from a point 300 meters from the launch pad for the balloon. So this must be my 300 down here. The angle of elevation to the top of the balloon is 25. So that's what this 25 is right here. That's 25 degrees. And then what's the change in altitude to the nearest meter for the balloon over 2 minutes from the first to the second observation? All right. So just to let you guys know what this problem is saying is, all right, at 10 o'clock, at 25 degree angle of elevation, we observed the balloon right there. All right, there's my balloon. And then 2 minutes later at a 60 degree angle of elevation, now the balloon is right here. And what I need to know is what was the change in elevation right here. So from balloon 1 to balloon 2, how far did it travel? All right, so I'm going to erase this in a second because I'm even embarrassed looking at this right now. Okay, you guys that are just joining us, number 4 in the packet right now, number 4 in the packet. So basically what I'm trying to find here is, here you go. What's this side length right here? X. From here to here. Knowing that that's 25 and then the whole angle is 60, we can assume that this is a right angle here. There's a couple of ways we could go about this. We could do law of sines. We could do sine, cosine, tangent. Here's what I'm going to do. what I'm going to do with you is I'm going to find the whole distance here, which I'll call y, and I'm going to find this distance from here to here and call it z. Because both, if you guys can see, side y and side z are both in right triangles, which will allow me to use sine, cosine, or tangent in a second. So I'm going to find side y and side z, and then my final answer, it'll be x will be equal to y minus z here. All right, so that's my plan. So let me start off by finding z. All right, finding z. Everyone see the small right triangle I'm working with right now? The one that has 25 degrees in it. So I say to myself, all right, the 300 looks like it's the adjacent to 25, and z looks like it's opposite. So if I have the adjacent and the opposite side, I can use tangent. Tangent of 25 is equal to my opposite side z over my adjacent side 300. I cross multiply because I'm finding a side, not an angle. I'm going to cross multiply. So z will be equal to 300 times the value of tangent of 25 in my calculator. Now when I find y, which is part of the big right triangle now. Y is part of the big right triangle. So I could say to myself, all right, let's see. If I wanted to find y, I can also use tangent. Because adjacent is still 300, and now y would be your opposite side. But instead of using 25, I'm going to use 60, which is the angle in the big right triangle. So I'm going to say tangent of 60 now equals your opposite side y over my adjacent side, which is still 300. So y will be equal to 300 times the tangent of 60. Find those values. Don't round, right? Don't round because I'm in the middle of a problem. So whatever I get in my calculator for z, whatever I get in my calculator for y, I'm going to take those full decimals and subtract them to get x. Then when I subtract them, then yes, I'll round it to the nearest meter. Whew. Everyone all right there? Or do you want, maybe, tell me too here, guys. This is your review here. All right, I'm here for you guys. Maybe if you want to chime in and say, hey, I was thinking about doing law of sines for that instead of using tangent. Instead, chime in with that. We can talk about that too. But here's one way to go about this problem. And yes, there are other ways I'm seeing right now that I could have solved for x without using tangent. All right, where else do you guys want to go? Keep talking to me here.
Can we go over question 2 in the packet?
Question 2 in the packet. Let's see what we're looking at here. Sure. Just wanted to make sure I'm up to date with it. All right, I got myself a rectangle, so let me get a rectangle out here. There we go. It talks about what's the measure of a diagonal make, so let me draw in. Doesn't matter which diagonal you draw in because diagonals are congruent in a rectangle, so I'll just draw that one in. So 8 and 6. So I'll put 8 here, 6 here. I know I got a right angle. That gives me a right triangle. The measure of the angle the diagonal makes with the longer side. So according to my diagram, the longer side is 8. The angle that the diagonal and the side of 8 form is right here for me. So I want to find x right now, angle x. Everyone sees the right triangle we're dealing with? There it is. I'm going to go sine, cosine, tangent. Yes, law of sines is an option here. You got to do a little extra work to do law of sines. but I'm just going to do sine, cosine, or tangent. So from angle X, 6 would be my opposite side, and 8 would be my adjacent side. Remember, hypotenuse always located across from the right angle. So O and A, I can use tangent. So the tangent of my angle X is equal to my opposite side, 6, over my adjacent side, which is 8. Talk today in class. If you're going to find an angle, anytime you're finding an angle, I always want to use the inverse of whatever I'm using. So in this case, I'm going to do inverse tangent 6 over 8. And I'll go to my calculator, inverse tangent 6 over 8. And then nearest to the nearest degree. So I'm looking at 37 degrees there. Okay, 37 degrees. Other thoughts, questions, comments, concerns? Let's keep it rolling.
Can you do question 13 on the review word problems?
13, here we go. I did have that up there. There it is. Yeah, this one's one of the tougher ones by far. Ooh, baby. Okay, 13 on the Google Classroom ones. Okay. All right, so here we go. So not everything is labeled here yet. We got an angle of depression of 6 degrees. 5 minutes later, the observer measured and saw the angle of depression was 49 degrees. Got it right there. Determine and state to the nearest foot per minute the average speed at which the canoe traveled towards the lighthouse. Okay, so what we're asked to find is, well, first what I need to find is in between 5 o'clock and at 5 o'clock observed it 5 minutes later. Okay, so how many feet I need to figure out if I'm going to figure out nearest foot per minute. All right, I already know it's traveled. Where'd it go? 5 minutes later. I already know it's traveling 5 minutes. So what I need to find out is, all right, how many feet did it travel in those 5 minutes so I can divide by 5? All right, because it wants your answer in feet per minute. So I just wanted to show you guys what I'm about to do here. All right, feet per minute. All right, you got to find out the distance it traveled in feet from starting point to the ending point here. So this distance right here is what we're trying to find. Out of 5, why out of 5? Because it said 5 minutes later. So what I need to find most importantly is how many feet did it travel here. Okay, so what I'm going to end up doing here is making 2 right triangles out of this. All right, very similar to what I just did in this problem here out of your packet, number 4, except now it's talking about the bottom of the right triangle instead of the side of it. All right, so let me get rid of this and so I can get some colors on here. Okay, so here is right triangle number 1. All right, so let me first take that part because I need to find this distance here, which I'll call x. And then I'm going to subtract it from, just like I did in the previous problem, this right triangle here, which I'll call y right here. All right, to find that distance from each canoe now. All right, so that's my goal. So I think it might be easier if I draw these out instead of writing different colors. So let me draw the big dog out here. All right, I'm trying to find this distance here. Let's see, this is going to be, if I do alternate interior angles, 6 degrees. Okay, that matches up with the 6 degrees down below. So this is my 6 degrees here. And then I know the whole thing is 112 feet on the left, but that, so I can use, I can use 112 for that one, right? At 1.5. Just let me take a look. Did I subtract that? Yeah, I got to subtract the 1.5 out because that's not the, that's from the bottom up there. So I got to subtract out the 1.5, which is the canoe height. So I have 112 minus the 1.5, which gives me 110.5. So I say, all right, from my 6 degrees, I got opposite and I have adjacent. So I can use tangent again. So tangent of 6 is equal to opposite 110.5 over x. Since I'm finding a side, we can go ahead and cross multiply. So I got tangent of 6 times x equals 110.5. Divide both sides by the tangent of 6. So x will be equal to, you go to your calculator, 110.5 divided by the tangent of 6. All right. So let me go to the smaller triangle now to find that other side to subtract from that. So now I'm finding side y. Now I'm taking the smaller triangle, still 110.5 over here. But now my angle is going to be a little bit different now. Okay, now my angle is going to be different. And it's not, I know it's easy. The problem with here is you guys see the 49, so maybe some people automatically think that's 49. But if you guys take a look, that 49 that's given, written in the problem, is not alternate interior with that one. All right, because those bottom and top lines aren't parallel. Here are the alternate interior angles. Take a look. I'll do this in a highlighter in yellow. Everyone see that right there? Those are the alternate interior angles. So it's just not 49, it's 49 plus 6. All right, which gives me 55. So that angle down below is going to be 55. All right, hopefully that's the tricky part about this one. All right, that it's not 49, it's 55. That angle down there in that triangle. Okay, hopefully you guys see that, why I can't use 49. I can use the 6 because it was alternate interior with this one. Those are alternate interior. But hopefully you guys are seeing why 55 is alternate interior with the angle in my triangle. So then, all right, opposite, 110.5 still. Adjacent is the side I'm trying to find. Here we go with tangent again. Big tangent day for us. Tangent of 55 equals opposite 110.5 over y. Cross multiply, just like I did before. Find what y is. Don't round, leave your full calculator display. I do x minus y. That'll give me how far the canoe has traveled in feet, which will go right here divided by 5 because it said nearest foot per minute. Am I going to do something like that tomorrow to you? No, I'm not going to ask nearest foot per minute. I didn't prepare you guys for that. But hey, Maybe something like, hey, find that distance from what's the difference between the canoes in feet? Yeah, sure. Absolutely. All right. I'm not going to go as far and say, hey, to the nearest foot per minute, give me their speed. I'm not going to do that to you, but absolutely I could do what's the distance between the canoes now? Or I need you to subtract 112 and the 1.5 out of there, find those angles that you need, and use 2 right triangles. Peter, yes.
Why do you need to subtract 1.5 from 112?
All right, I didn't make the right triangle. Good. Here you go. This will probably help you. I shouldn't have drawn it from the bottom of the canoe here. Here you go. I should have just drawn it from the right here. Here's where there was one right triangle right here. Okay, that was one right triangle. I mistakenly drew the horizontal line I wanted wrong. And then here is your other right triangle, the smaller one I was talking about. So that's why I subtracted the 1.5. I was using those right triangles. All right. Okay, let's keep rolling here. Hey, let's keep discussing here. I know you guys got it. Just let it loose. Let it loose.
Can we do number 1 in the packet?
Number 1 in the packet. Yep. The rhombus one.
Yeah.
Yep. Okay, rhombus contains a 60-degree angle. The length of each side is 10. Okay, find the shorter and the longer. All right, I'm not concerned that I find the shorter first and the longer second. I'm just going to find whatever diagonal I want first, and then I'll find the other one. Because remember, diagonals are not congruent in a rhombus. So here we go. Let's start, because we do need some properties of a rhombus here. So let me draw in the first diagonal right now. Boom, right there. There's my first diagonal. One property of a rhombus and their diagonals is they bisect the angles they're drawn to. So now I have 2 30-degree angles right there. Let me draw in the second diagonal now. Diagonals are perpendicular. So I have a right angle there. Now we could go about this a couple different ways. Sure, you could use sine, cosine, tangent, maybe law of sines here, but hey, what do I see right now? I see a right triangle. One angle is 30, and I know there's 180 degrees in every triangle. That bad boy's a 30, 60, 90, isn't it? Okay, that's a 30, 60, 90 triangle. And since we don't talk about it often and it'll be on the test tomorrow, let's talk about it. You could still do sine, cosine, tangent, maybe some law of sines here. You guys could. All right, but I think it's better if we just focus on 30, 60, 90 right now. So everyone take my 30, 60, 90. Anybody know what the 10 is in that 30, 60, 90?
The hypotenuse.
Hypotenuse. All right, so let me start by finding, I'll put an X, the shorter leg right there. The one across from the 30. Anybody remember how was the shorter leg and the hypotenuse related in the rules we wrote down today? Shorter leg was equal to what? Hypotenuse was equal to what in a 30, 60, 90?
2 times the shorter leg?
2 times shorter leg. All right, what are we working with? X is my 10 is my hypotenuse equals 2x. What's my shorter leg? 5. So x is 5. What do you guys know about the diagonals of a rhombus? They bisect the angles, they're perpendicular, and they also bisect each other. So if that piece is 5, the other part of the diagonal is 5, so at least I know one diagonal is equal to 10. I don't know if that's the shorter or the longer because I got to find the other one. Ready? All right, go back to my 30, 60, 90 triangle now. I'll call this longer leg is y. The longer leg is y. How do we find the longer leg when we wrote down the rules today?
Short leg, radical 3.
Short leg, there we go, times radical 3. So my longer leg is going to be 5 radical 3 because I just found the shorter leg to be 5. So this is going to be 5 radical 3. And I know I'm making a mess here, but I'll draw an arrow instead. 5 radical 3 because they bisect each other. So the other diagonal is 10 radical 3. So that looks like it's the longer one. So the longer one is 10 radical 3, and the shorter one is 10. Just using my 30, 60, 90 rules. Now let's say you found the shorter leg to be 5. You could do Pythag after that, right? 5 squared plus b squared equals 10 squared. Got so many different ways to be able to accomplish the final goal. Now, if you did use sine, cosine, tangent to do this problem, you probably would not get 5 radical 3. You'd get the decimal version. So hopefully, it would say nearest 10th. But I can tell you tomorrow on the test, the problem that involves 30, 60, 45, 45, you do need to leave your answer in radical form. Okay, you do need to leave your answer in radical form tomorrow. And the only properties of a quadrilateral you'll need to know are a rectangle, opposite sides are congruent. There you go. That's all you really, but I think you guys know that already. So, all right, that's the only thing I'll let you in on. Something's going to involve a rectangle tomorrow. Opposite sides are congruent. You don't need to get in any deeper to the properties other than that. And because, you guys know this is probably why you show up, right? Most importantly is to get inside info on the test. The multiple choice questions tomorrow, all multiple choice questions tomorrow pertain to law of sines and law of cosines. That's about as much hard-hitting inside info I'm going to give you during this review session. The 3 multiple choice questions deal with specifically law of sines and law of cosines. So please make sure you know those 2 formulas because you will need them. There is no other way to do those problems tomorrow. The word problems, that's fair game. That's up for anything tomorrow, those word problems. I can't tell you let me put it this way. The word problems, I can't tell you what they're about because you may do it one way and somebody else may do it another way. So I can't say, hey, word problem number 1 is going to be using law of sines because somebody might use sine, cosine, tangent and be correct about it. All right, go ahead. Keep it rolling, guys. Keep it rolling.
Can you go over question 10 on the PDF?
Question 10. Okay, with the airplane and everything else. Okay. Again, just not to frustrate you guys, I'm just going to fill in everything that needs to be filled in because that's what I'm going to do for you tomorrow. Angle of depression of 28 from point A. All right, so this would be my 28 from point A. And where's the other one? 34 degrees from point B to the same tower. Okay, so there's my 28 and 34 for angle of depression. Find the distance from A to B. Okay, find the distance from A to B. We'll assume that's a right angle. That's 50 here, so if I draw this over here, that's now going to become 2,000. So I have two right triangles right now. All right, let's see. How do I want to approach this one with you guys? I've already done sine, cosine, tangent. So why don't I try to do a little law of sines action here if I can? I think I'll do that. I'll do a little law of sines. All right, so what I'm going to try to do is, now I'm going to find every other angle I can possibly find. All right, what other angles can I possibly find? Well, I see 28 degrees and the angle adjacent to it makes a 90-degree angle. And yeah, I got it. I'm doing this. I have no shame. 62 degrees. All right, so this will be a 62-degree angle here. Hopefully you guys see that they add up to 90. The one next to 34 is supplementary. 180 minus 34, 146. So this angle right there is 146, which would make the third angle in that triangle. Let's see, 146 and 28. You teach honors math and you are 6 degrees and you're using a calculator. That's 6 degrees. All right, here's my plan, everyone. Everyone see the small triangle that's got 146, 28, and 6 degrees on it? I'm about to do law of sines with that to find x. I'm about to do law of sines with it. So if I started out law of sines, I'd say side x over the sine of 6. Everyone with me so far? Equals, okay, now I'm running into a problem. I need to know another side, right? I need to know another side to plug into the law of sines, because what I tried to yell and be as intense as I could today in class, if I'm going to use law of sines, all 4 values you plug in need to come from the same triangle. All 4 values need to come from the same triangle. So I need to find another side length other than x in that small one. So what I'm going to do is I'm going to find this side right here, y, by using the other triangle next to it. So I'm going to do another law of sines. Take a peek, take a peek. Y over the sine of 90 equals 2,000 over sine. I didn't calculate that angle, did I? 90 minus 62, 28 degrees. Over sine of 28. Everyone see why I'm doing law of sines twice now. One law of sines is finding side y in the right triangle. And the second law of sines is going to be finding x in the triangle that contains 146, 28, and 6. Sarah, go ahead.
Sorry, I
Nope.
have to log soon, but before I do, I just have a quick question. Can you put an x in for one of the denominators in law of sines?
You can, but you got to put sine x.
Okay.
And that means you're finding an angle, Sarah, which means at the end, you should be doing inverse sine.
Okay. Good.
Just don't put plain x, sine x. Okay?
Okay, thank you.
Yep. So everybody good here. So now I'm going to do sine of 28 times y equals 2,000 times sine of 90. Divide that by the sine of 28 on this side to get y by itself. Whatever I get here, whatever that decimal is, you better believe I'm not going to round it. I'm going to put it over here because that's my other side. And then what angle is across from that side in the skinny triangle? That would be 146. So sine 146. I'm hoping you guys see. Notice how anytime I used law of sines, all 4 values came from the same triangle. All right, all 4 values came from the same triangle. All right, so I did that problem using law of sines. Is there other ways? Probably. All right, but I haven't done law of sines yet, so. Okay, so there's number 10. Let's keep rolling. What else?
Can you do a Hills and Sass word problem?
Sure. I think I got to go to your packet for that one towards the end. I know I put some Hills and Sass on there. I don't know if it won't be a word problem, but at least you can tell by the Oh, there you go. Here's your word problem. Some of you may recognize this. I don't know how good your memory is. You have seen this before on a previous quiz. So number 17 in your packet. Very last question, actually. Guys, you know something? I'm not even, and I get it. Yeah, I know. I'm the math teacher, so I see this right away. But I'm not even reading anything in the problem yet. And I'm just staring at that diagram, and I know it's going to be Hill-Sass. Does everyone see triangle EFP is a right triangle? And the altitude is being drawn from the right angle. Just by looking at that diagram, I'm like, boom, that's got to be a Hills and Sass one right there. Just by the diagram alone. All right, now let's label it. Poplar Street is 12 miles long. And the distance on Maple Street from E to M is 10 miles. Find the length in miles of Maple Street. So this entire length right here I'm looking for. All right, so I'm looking at what I have right now. And if I know my pieces of Hills and Sass, I'm trying to find the hypotenuse when I'm given a leg, which would be your 12, and it looks like 10 would be a segment. So it looks like based on what I'm given, H, L, and S, I probably want to use Hills here. All right, so here we go. See if I can catch anybody in a trap. H is for hypotenuse. That's what I'm trying to find. So I called that X. L is my leg, which is 12. We talked today in class. The legs are equal. Here's the trap you don't want to fall in. I'm not putting 10 for segment. Why not? Why could I not put that 10 miles in for S right now?
Because it's not adjacent to the leg.
Darn right, Melinda. Great job. That 10 miles EM is not adjacent to the leg I'm using. The S in Hills stands for the segment adjacent to the leg, which is 12. I actually have to put in MP. Well, I don't want to introduce another variable, do I? But can you guys find out using X and 10? How can I label MP? MP. Without using a different variable, how can I label what MP is?
X minus 10.
X minus 10. There you go. There it is. Using Hills. Please understand why you just cannot plug in 10 for S. It is not adjacent to the leg I'm using in Hills. And then from here, there won't be any factoring tomorrow, even though you have to factor on this one, I know. No factoring tomorrow. Move over the 144. And then you guys can play around two numbers that multiply to 144 but add to 10. I think it's 18 and 8, if I remember this problem correctly. Minus 18 and plus 8. So you get x equals 18, x equals negative 8, but that's kind of foolish, right, to have a negative side length. So -8's gone. There it is, 18. 18. Pretty good word problem right there. Again, take a look at the diagrams tomorrow. The hills in SAS one will probably stand out because you see a right triangle with an altitude being drawn from the right angle. It'll stand out tomorrow. Also, a reminder on any hills SAS diagram, Pythagorean theorem is always an option too, if you have enough information. Pythagorean theorem, always a great option. All right, guys, I got about 5-10 more minutes here myself, so go ahead and get your questions in.
For number 8 in the packet, I got number 2, but like on the answer key it says it's number 1.
Oh boy. Oh man, 5'9". Cast a shadow, so we're doing right triangle. Guy 5 feet 9 inches. To the ground, cast a shadow of 8 feet 6 inches. Assuming the man is standing perpendicular, right angle, what's the angle of elevation, which would be this one right here, ground up, from the end of the shadow. Okay, so there it is. That's the one I'm looking for. All right, so I need to first, because I can't have feet and inches here because I don't know how I would put that into my ratio. What you convert it all into? Inches or feet?
I found the problem.
Okay.
I just put 5.9, yeah.
Yeah, it's a little bit, 5.9, a little bit different. I think it's 5.75 if you want to leave it in feet, 9 out of 12. Or heck, I would just change this bad boy all to inches personally. Just 5 times 12, add 9, 8 times 12, add 6. Change that all to inches. Where else are we going here? Where else?
Number 5 in the packet?
5 in the packet. Don't worry about it. That stuff won't, that's, sine of 50 equals cosine of 40. That stuff won't be on there tomorrow. That sine and cosine are equal when their angles add to 90. That will not be on there, so don't worry. Again, just remember, guys, this, the review I'm giving you is from review past years, which I would have had on a unit test, but considering the conditions, I did not feel appropriate to put every single little detail on. Because trust me, you'll get grilled enough tomorrow. Anything else? All right, if there's nothing else, then guys, get some rest. All right, get some rest tonight. All right, don't freak out. All right, I think you guys will do just fine. Please, either don't freak out. There's a lot of topics on here, I know, but remember, there's more than one way to get to the answers tomorrow on those word problems. All right, there'll be more than one way to get to the answer. Do what you're comfortable with. All right, stay within your comfort zone tomorrow. Label all the angles you can. Maybe that'll help you out if you like to do law of sines. Just remember, if you're going to do law of sines, all values have to come from the same triangle. All right, guys, I appreciate you hopping on at this time of the day. I know way past your school day, but I appreciate it, the extra time you guys give and all the hard work you guys put in. I know it'll pay off for all of you tomorrow. If you have anything extra, email me. All right, I'm sure it'll be a late night here for me, so email me tonight if you got any questions. All right, guys, I'll see you tomorrow.